My name is Ian McCallum. I'm a researcher at the International Institute for Applied Systems Analysis in the Ecosystem Services and Management program, and I'm going to be speaking today in regards to Earth observations and climate mitigation. Earth observations began in earnest from space in the early 1970s with the launch of the Landsat program, and the entire Landsat archive was recently made open and freely available, so we now have at our fingertips over 45 years of information coming from satellites. Here I'm referring to the Landsat timeline, so you see the various missions that make up the Landsat archive, and what we see here is that we have essentially a continuous time series from the last 45 years with more or less overlap between the various missions, meaning that we have basically an unbroken record of environmental monitoring from space. Now, the Committee on Earth Observation Satellites is actually managing the currently over 350 active missions or instrument combinations that are in space right now, and they've been doing that since the 1980s, and as we have had more and more launches occurring, they're continuing to monitor this growing amount of information that we have available. And I just want to show you here in this image a few products, in particular agro-meteorological products. There are numerous examples which exist of satellite-based global products, in particular soil moisture or temperature, precipitation, photosynthetic active radiation. And these become then the input data sets that we need for climate mitigation strategies and vulnerability measurements, for example, looking at soil carbon vulnerability to drought. We have a suite of satellite-derived biophysical products that we now have at our fingertips to use for a variety of applications, including FAPAR, LAI, various vegetation indices, land cover, and more. And these data sets provide input for the biophysical models on the one hand, but also for monitoring and evaluation of policy success. One example of this would be monitoring of deforestation policies to prevent deforestation, and with satellites we can actually detect where that is potentially still occurring. Now I want to move to some of the more recent European Space Agency missions which are now coming on stream, and we have a variety of different new satellites in the last decade or so that are coming online and will provide an ever more increasing amount of information, in particular the Sentinel satellite series. The 3 Sentinel satellites which have been recently launched in the last few years. It's the Sentinel-1 product, which is a radar-based product, which will be measuring both on the oceans, over the oceans, and over land. And then we have the Sentinel-2 product, which is an optical product, which focuses on land measurements, and Sentinel-3, which focuses in particular on the oceans. I have just a few examples from that here coming from the Sentinel-1 radar product. This is rice planting and harvest calendars, which are being then determined from satellite imagery. And we are able to, here with the satellite products, to determine actually the planting dates and harvest dates that have occurred throughout the year with various products, in this case being rice. And this would then, of course, allow us for planning for climate-smart agricultural practices. So if we need to then adapt to varying changes in the local climates, we can then perhaps shift these planting dates and adjust the crop calendars or adjust the species which are being planted. So this is a very nice example of a new product that is available from the European Space Agency. And the second product here is in relation to irrigation monitoring at the field scale, at the local scale. This is coming from the Sentinel-2 product, which is an optical satellite launched actually very, very recently. And here we can see water consumption for irrigation of summer vegetation, which is appearing in this image on red. With this satellite, we are able to monitor water use effects, in particular N2O emissions, because of very high productivity occurring in these fields, which can actually lead, on the one hand, a positive effect, land sparing elsewhere, but also can lead to very localized problems in that region in terms of water consumption. So in summary, I would like to say that there is a very long archive in existence of environmental observations from satellites, greater than 45 years now, and this continuity is very important for planning, monitoring, and evaluation of various climate policies. We also have a lot of new satellites coming online with improved temporal and spatial characteristics. This then means that the situation is actually improving. We are then having at our fingertips an ever-increasing amount of data from which we can derive new information. We also have Earth observations from satellites which hold a great promise for monitoring global phenomenon, allowing us to revise our climate targets if we need to. So if we see actually that climate change is having more impact in a particular area than we anticipated, we can potentially then modify our actions to adapt to those situations. Missing, of course, in this whole top-down view that I'm speaking about here is the need for in-situ information, so on-the-ground information, local information, not only to calibrate and validate the satellite products, but also to measure the many important socioeconomic variables that exist, and these could be in relation to poverty or hunger, and in particular that would address the various SDGs.